Hello. In this tutorial, we will learn about grouping data. We will learn about tally charts, frequency tables, and grouped frequency tables. When collecting data, it can be helpful to have a data collection sheet. A data collection sheet is a tally chart or frequency table where data can be recorded. Let's have a look at an example. Mark noted down the different types of bird that visited his garden. Here's a list of the data. This data is qualitative data. That's qualities. The quality of each bird is its type. It's also categorical data because the type of bird forms a category. Let's have a look at the tally chart and frequency table. The first column is always the data. In this case, it's type of bird. And I've listed the type of birds here. The next column will be the tally, and the last column will be the frequency. And frequency simply means how many. So let me start tallying this data. The first data is a crow, so I'll put a tally mark here by crow. And then I cross off that piece of data. Pigeon. Robin. Another robin. Do remember that we tally in groups of 5. So I've just got to another crow. I'm going to cross through that group as it's the 5th crow. There is another format for grouping your tallies in 5, and that would be to do a box with a bar across it like this. 1, 2, 3, 4, 5. And then I've grouped them as a 5 and I can count them up more quickly. You'll notice now I've reached the 5th magpie. Now I've finished the tally, I can fill in the frequency. The frequency here is 2. I'm just counting up how many tallies there are. 5 and 2, 7. 7. 6. 3 and 5. Finally, I'm going to total, and this is a check to see that I've counted all of the data. I come to a total of 30, and I can quickly count up. They're actually in rows of 10 and see that I've got 30. So yes, I've made sure I've tallied them all. Now, if there's a lot of data, it can be grouped to help organise it. This can also help show the distribution of the data and help spot patterns. Discrete data, remember that's data that's been counted, can be grouped into classes that do not overlap. For instance, 0 to 9, 10 to 19, 20 to 29. Notice I couldn't possibly have 0 to 10 and then another group of 10 to 20 because this actually overlaps here. If I have the number 10, where would it go? It could go in this group and it could go in that group. Well, we don't want this confusion. We want groups to be clear and only data going in one group or the other. Mark noted down the number of birds that visited his garden each day for 30 days. Here are the number of birds. Now again, I'm going to set up a table, very much like the previous one. The first column is always data, number of birds. Then we have a tally column and a frequency column. Here I've filled in some classes, 0 to 4, 5 to 9, 10 to 14 and 15 to 20. You'll notice that there is no overlap. I'm sure where to put 4, I'm sure where to put 5. And then it's the same process as tallying, but this time we put the number in its correct group. So I've finished the tally. Now I can count up my tallies and fill in the frequency. Each of the groups is 5, so I can quickly count that up to be 5, 10, and 2 more is 12, 10, 9, and 8. Let me count up that data, that total. That's 22, 39. Let's count, make sure I got them all. Yes, I counted, there are 39. So I've tallied and totaled correctly. Now, this data is quite evenly spread over the classes, but the intervals don't have to be equal width. It's best to use narrower intervals where there's more data closer together, and to use wider intervals where there is less data. It's more spread out. But yes, I was fortunate here, the data was quite evenly spread and there is a similar number in each group. Now, continuous data can be grouped into classes that don't have gaps or overlaps. We do that using this less than or equal sign and this less than sign. So this would read that 50 is less than or equal to t, which here stands for time, is less than or equal to 55. And 55 is less than or equal to t, is less than or equal to 60. Now, we've repeated the 55 here, but there is no confusion, because on this side we have an equal sign, and 55 would go in this group. Here we don't have an equal sign, so 55 would not go in this group. Let's see an example. Mark noted down the time in seconds each bird spent visiting his garden. Here's the data. Again, I've set up a tally chart. Here is the data, time in the garden in seconds. And I've put the class intervals here, and they're all ready to go. So let's start tallying. So 80 is interesting because it's clear I don't put 80 here, there's no equal sign, so 80 is going here. Where there is 80 is less than or equal to t, so the equal to t says put 80 there. 65, well, it's clear we won't put it here because there's a less than symbol, no equal symbol. We will put it in this group because 65 less than or equal to t, so there's an equal sign there, 65 will go here. Again, I'll fill in the frequency. See how quick it is because I remember to bundle them up in fives. I'll do a total, 30. Yes, there are 3 lots of 10, so 30 is correct. Now, do notice that these class intervals were not of equal width. This one is 70 to 80, a bigger class width than the other intervals. This is what's called an open class because it doesn't have an upper bound. Okay, numbers here are just greater than 80, greater than or equal to 80. Now, that can help if the data is very spread out at this upper end, maybe with some big numbers. We didn't here, they were all quite close to 80, but they might have been. So again, intervals don't need to be equal width. You can use narrower intervals where there's more data, and you can use wider intervals where there's less data. Now we're going to look at the case of rounded numbers. We have to be careful and treat them as a special case. I'm going to take my height of 152 centimetres to the nearest centimetre as an example. This is the height that I've put on my passport, or that I put on forms when asked. Now I measured it with a tape measure that showed millimetres, but as I was rounding, I went to the nearest centimetre on the tape measure. So what height is the smallest height I might have measured on the tape measure? If you know about rounding, you'll know that I could have measured as small as 151.5 centimetres. And the rule with rounding is that if this is 5, we go up to 152. So that's the smallest it could have been. Now, what's the greatest height I might have measured on the tape measure? Well, again, if you know about rounding, you know that if I get to 152.5 centimetres, the rule would be to round up. So I need to be a bit less than that. I can be a very small bit less than that, and I would round down to 152 centimetres again. So I can actually show this range of values. I'm going to use h for my height in a similar way to the way I did with my class intervals in the previous example. My height lies between 151.5 to 152.5 centimetres. Again, don't worry about this being the 152.5. That's permissible because there's no equal sign here. I'm not suggesting I was as tall as 152.5 because that would round up. I'm saying I'm less than that, so I would round down to the 152. So all the values in that range will round to 152 centimetres. Now, we must think about this when we're looking at rounded data. So in this final example, we'll look at how we cope with rounded data. We will group it in a similar way to continuous data. Let's take a look at this example. Mark noted down the time rounded to the nearest second each bird spent visiting his garden. Here's the data. We're going to look at this final value of 65 as an example. So 65 rounded to the nearest second. Let's consider the range of values that might be. T is for time. Now the very smallest reading I might have on my stopwatch would be 64.5. That rounds up to 65 seconds. Anything as large as a little bit less than 65.5 will get rounded down to 65 seconds. Again, notice here I don't include the equal sign, so I'm only considering values less than 65.5. So let's consider where this might be recorded in our groups. Well, if it's as small as 64.5, it would go in this group. But if it's as big as 65.5, it would go in this group. And so we see we have some ambiguity about where to put the value of 65 rounded to the nearest second. So what we're going to do is we're going to change the class boundaries slightly. Let me show you. So let's consider the value of 65 first. Now, if we increase this slightly to 65.5, and that also to 65.5, there's no ambiguity now as to where that value of 65 goes. It will go into this group here. So I'm going to change each of the boundaries in that way. That becomes 55.5, 55.5. That will become 60.5. We've done the 65.5. This will become 70.5. and finally 80.5. We must also change the beginning, but here we're going to go down slightly because a value of 50, well, that could be as small as 49.5. So if I do have a value of 50, it would now go in the first class here. So let me start tallying the data as I have it. So now there's no ambiguity. 54 is here. 58. So here 70. 70 has been rounded, but it's clear it goes in this class here. Now that 80, again, could be as large as 80.5, but it's very clear it's in that class. 60, well, that was on the boundary before, but it's clear it goes here. It could be as large as 60.5. Again, 55 on a boundary, could be as large as 55.5, but it's clear it goes in that one there. And finally, our 65, which we agreed would go here. Now I'll count up the frequencies. Doing a total quickly, I have 30, which is the total amount I wanted. So you can see how we cope with grouping data even when it's rounded.